Hi everyone, it's Alyssa and welcome to Tricky Math Tuesdays. Today's tricky math problem has some geometry in it, and we're given this image. And here's what we're told. We're told we have a triangle inscribed in a circle. Okay. We are told that AB is congruent to BC. We're told that the measure of angle ABC is 68 degrees. And the question is, what is the measure? I just cannot write neatly on a laptop screen to save my life. What is the measure of angle BDC? And D is the center of the circle. So, for these sort of things, my first action I want to take is I start drawing. I want to draw on this picture everything that we're given and also take note of what they want us to find out. So I'm told AB is congruent to BC. Okay, AB congruent to BC. Okay. Measure of angle ABC is 68. All right, so ABC is 68 degrees. And what they want to know is what is BDC, which isn't on here, so I'm going to draw it in. This is what they're looking for. BDC. This is my question mark. What is this? Okay, so first things first. I'm going to look at this and take stock. I have a triangle with two congruent sides. That means it is, class, isosceles. Well, my chair just squeaked. You can hear that. It is isosceles. It has two congruent sides. Now, there's a little interesting fact about isosceles triangles that they are kind of expecting you to know. And it is, if I have an isosceles triangle, no matter, wow, those are awful. No matter what shape it is, if I have these congruent sides, then these base angles down here are congruent to each other. Right? So let's go back over here and say, okay, now I know that these two angles are congruent to each other. Well, how does that help me? That helps me because the interior angles of all triangles add up to 180. So angle A plus angle B plus angle C together are going to equal 180. Well, I know angle B is 68 degrees, and I know angle A and angle C are the same. So I'm going to call them both X. Okay, so if I combine like terms, 2x plus 68 equals 180. I subtract 68 from both sides, and I get that 2x equals 112. If I divide both sides by 2, since it's 2 times x, I'm undoing that by dividing, I get that x equals 56. All right, I've got another piece of information. Now I know that angle A is 56 degrees and angle C is 56 degrees. All right, that's cool. So now, what's my next step? There's another piece. A lot of these problems, they are not giving you all of the geometry facts. They are assuming there's some theorems and facts about circles and triangles and stuff that you know. So first we had that the base angles of isosceles triangles are congruent. Here's the other thing they're wanting you to know. If I have a circle, yep, assume that's a circle. It's close enough for our purposes. It's kind of a circle. If I have a circle and I draw an angle somewhere in it, and the center of the circle is the vertex of that angle. This arc that is created by where the angle, touches the circle, this arc can be measured in degrees. It's not a length measurement. Think of it more as a percentage measurement. It's how much of the circle, what percent of the circle when we're talking about degrees. As we're saying, if I divided this circle, if I went around, I started in the center and I went 360 little lines all the way around, how many of those little lines would I be, using? I'm taking a couple of seconds to explain this because this is something that, frankly, a lot of students will get confused with circumference and degree. It's just like an angle. It doesn't matter the size of the circle. It's just saying what percentage, what portion of the circle that arc is. So here is a visual example. That's a 90-degree angle, right? And this arc is a quarter of the way around the circle. A circle is 360 degrees, 60 degrees. What is a quarter of 360? 90. So this angle is 90 and also this arc is 90. Conclusion. If I have an angle that the vertex of the angle is the center of the circle, the measurement of that angle and the measurement of the arc it is intercepting are the same. So, what does that mean for our little problem? Well, when we go over here, this angle right here, the one I need to find, is intercepting this arc. So if I can find the measure of that arc, I can find the measure of that angle. Well, squeaky chair, there's one other circle fact that they're counting on you to know, and that's if, there's so many of these little circle facts, if I have that same arc and I have another angle, but the angle this time, it's not at the center. No. The vertex is on the circle somewhere, and it doesn't matter where. It's kind of cool that way. If this is 90, this is now 45. If the vertex moves to the outside of the circle, it becomes half of the arc that it is intercepting. So what does this mean for our little triangle and circle situation over here? Well, I'm going to kind of draw it isolated so you can just see. So if I have this triangle and there's my A, there's B, there's C. What if I just did just this? I got rid of everything else. I said, okay, this is 56 degrees. What is this arc? Well, I know the angle is half of the arc, so I need to multiply by 2. 56 degrees times 2 is 112 degrees. This arc is 112 degrees. Well, now I'm going to look at, same thing again, A, B, C. What if I'm looking at the angle B, D, C? It's intercepting that same arc of 112 degrees. Well, my other little rule says if I have an angle and the vertex is at the center, then its measure and the measure of this arc are the same. Dun, 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 that means, yay, my angle at the middle is 112 degrees. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.